Hello everybody, welcome back to IDAE Infinite Digital Academy for Engineering, and in today's video we'll be talking about balance inequality in mathematics. Alright, so here we have a balancing system, right? We have a balancing system with 5 balls in the left and 5 balls in the right. Right, now we represent this mathematically by saying 5 equals to 5. This 5 represents to those 5 balls, and this 5 represents to those 5 balls, and this equal sign represents to the balancing system, which is in balance. Right, now if I remove one ball from this side, the balancing system is no more in balance, and we represent this mathematically by saying 4 does not equal to 5. 4 is not equal to 5. All right, because we have 4 balls here and 5 balls here. Now, this not equal sign represents the imbalanced system over here. Perfect. So let's come back to our original balanced system. We had 5 balls and 5 balls in this side. Well, think of it. If I want to remove one ball here and still make this balancing system be in balance, I can do this through getting one ball out from this side and getting one ball from this side, right? So when I remove one ball here, I have to remove another ball from the right side. So now the system is in balance. Okay, perfect. Now we can represent this also mathematically. We can represent this by saying, all right, so we get 1 from the left side and we get -1 from the right side. And we still have a balance, which says 4 equals to 4. And this is perfectly true. Okay, perfect. Now you can see this is the same thing. This equation can be manipulated just like this balancing system. When you have anything here, when you add 2 balls, you have to add 2 balls over here for the balancing system to be in balance. Now, in mathematics, we say when you add 2 to this side, you have to add 2 to this side for this equal sign to remainder. All right. Now this is what we do in mathematics. Whatever we do in the left side, we have to do it in the right side for this equal sign to be true. Okay, perfect. Now let's move on and let's get into such an example. We have 5 balls and we have a box. Now this box has got some balls in it, but we don't know how many balls in it, right? We don't know yet. It's closed and we cannot see. So we have 5 balls and a box over here, and we have 8 balls from this side. But one thing we know is that this system is in balance. You can see it's in balance. It has no tilting, right? Okay, perfect. So let's check it out. We can represent this mathematically by saying 5 plus x equals 8. Now 5 balls represent to this 5 plus x. Now we don't know how many balls is this box, all right? So we just tend to say x or a or b or c or just something to put it there, so to represent that we don't know yet. Okay, equals 8. Now the most important thing we know that this system is in balance, all right, because we can see it. We put it there and there is no tilting, so we know that this side is equal to this side. Now to find out how many balls are in x or how many balls are in the box, we can do one thing. We can remove 5 balls here, right, because we have 5 balls from this side. So we can remove 5 balls and we're left only with this box. But then we have a problem. If I remove 5 box from this side, the system will not stay in balance. So I will remove 5 balls here and I will remove 5 more balls here. So I will have my box alone with balls here. Okay, so let's just check it out. So we remove 5 balls from both sides, all right? Remove 5 from this side, remove 5 from this side. We get this equation, right? Okay, now this is the equation we got. We get x equals 3. 8 minus 5, 3, and 5 minus 5 gives us only x over here. Okay, so now we can see that this box is in balance with only 3 balls. So we know that this box is the same thing as 3 balls, right? Or mathematically, we can say x equals 3 or box equals 3. All right, perfect. Now let's get another example. Now in this example, we can see that 5x plus 10 equals 0. Perfect. But let's check it out. So if we want to find x, as we said, x is just a box, all right, which we don't know how many balls are in or how many kgs it is. So we represent this by x, y, a, b, any variable, you can name it, all right? So we have 5x plus 10. Now remove 10 from both sides, and the reason we remove it from both sides is to get this equal sign work again. Okay, so we remove 10 from both sides, and then we get 5x equals negative 10, right? Perfect. 5x equals negative 10, because 0 minus 10 gives us minus 10, negative 10, and 5x plus 10 minus 10 gives us 5x alone. 10 and 10 turns out to be 0. Okay, so now still we need to get x alone. We know 5x is negative 10, is the same thing as negative 10, but we need to know what is x, right? So to do this, we divide both sides of the equation by 5, all right? So we divide both sides by 5, which gives us 5x over 5 equals negative 10 over 5, which is x equals negative 2, all right? Perfect, perfect, perfect. So here we can see we have an x which is negative 2. But let's just think of it. What does it mean to have a negative 2, right? I mean, let's just think of this as a balancing system again. We have something in the right, but we have nothing in the left, and still they are in balance, right? So the box has to have some negativity. But what does negative t mean? I mean, negativity does not make sense, and it's not real. We don't face it in real life. But one thing that is important about this negativity is we use it in theory, and it turns out to be very, very useful. It turns out to be very useful while solving theoretical questions, theoretical stuff, and apply them in practice, right? So negative numbers are not there in real, but we use them and they're helpful. They help us to do practical things, right? Okay guys, that's it for this video. Thanks for watching. Don't forget to subscribe, like, comment, and share.